Welcome to Lewis dot structures.
These structures were originally created by Gilbert Newton Lewis and are utilized in order to demonstrate how the atoms of compounds bond together.
Bonding occurs between the two atoms' valence electron shells, the outermost electron shells.
Our first atom is neon. By looking at this model, we will decipher step by step how to construct a Lewis dot structure from its chemical formula. The first step is to find the number of valence electrons in each atom. In this case, we need the number of valence electrons in the element neon.
According to the periodic table, neon has 8 valence electrons. This means the Lewis dot structure must have an N total of 8 electrons, as these structures represent only the outermost electrons of each atom in the formula.
Because there is only one element in this Lewis dot structure, the symbol Ne surrounded by 8 electrons is our final product.
Our second example is a central carbon atom with a bromine and 3 hydrogen atoms. Since carbon has 4 valence electrons, it has the most places for bonds to occur. It is the central atom. Carbon has 4 valence electrons, bromine 7 and hydrogen 1. There are 3 hydrogens, so there are 3 electrons. 4 plus 7 plus 3 is equal to 14. This is the amount of total electrons the Lewis dot structure needs to have surrounding it. Attach the 3 hydrogens to the carbon, which satisfies the hydrogen's duet rule. Then attach the bromine to the carbon, which satisfies the bromine's octet rule. Since the carbon has 4 bonds attached to it, and each bond has 2 electrons, the carbon's octet rule is satisfied. Count the number of electrons in the drawing. There are 8 between bromine and carbon, and 6 between the hydrogens and carbon. 8 plus 6 is equal to 14. Since the substance has the number of electrons needed, the drawing is complete.
In this model, we have a phosphorus atom, which is a central atom, and 3 chlorine atoms. Again, we count the total number of valence electrons in each atom, which will tell us the total number of electrons in the Lewis dot structure. With 1 phosphorus and 3 chlorine atoms, the number of electrons will be 26, which takes us to assembling our model. We note the symbols of the atoms and write the phosphorus symbol in the middle surrounded by 3 chlorines, all bonded with a shared pair or 2 electrons that belong to both the phosphorus and the chlorine atom. We then fill in the remaining 20 electrons, first on the chlorine atoms. Once we've reached 8 electrons on each of these atoms, however, we still have 2 electrons left to place. Here is where a lone pair comes in, and we will place this on the empty side of the phosphorus atom, not bonded to anything but the phosphorus. Double check your number of electrons, and you have the Lewis dot structure for phosphorus trichloride. In this next example, we have iodine and bromine. As always, we count the total number of valence electrons in each atom, which will determine our total number of electrons in this model. In this case, the total electrons in the Lewis dot structure will be 14, which leads us to our next step of forming the actual model. We take the symbols of the atoms, iodine and bromine, and draw them bonded together with 2 electrons. We then fill in the remaining 12 electrons, resulting in 8 total electrons on each atom with 1 shared pair. This is the final product.
The next example is oxygen difluoride. The central atom is oxygen, which has 6 electrons, and 2 fluorine, which have 7 electrons each. When bonded together, they equal 20 electrons. When you fill in the atoms that oxygen has to have, you have 2 more bonding locations. This is the perfect place for fluorine to bond with the oxygen to where the oxygen would have its complete 8 electrons, which pleases the octet rule, and the 2 fluorines would also meet the octet rule by sharing 1 electron with the oxygen. When you count all the electrons up, you have 20 electrons, which is what you should end up with. This is the final step in completing a Lewis dot structure.
Our next example is a central nitrogen atom with a chlorine and 2 hydrogen atoms. Since nitrogen has 5 valence electrons, it has the most places for bonds to occur. It is the central atom. Nitrogen has 5 valence electrons and chlorine has 7. There are 2 hydrogens, so there are 2 electrons. 5 plus 7 plus 2 is equal to 14. This is the amount of total electrons the Lewis dot structure needs to have surrounding it. Attach the 2 hydrogens to the nitrogen, which satisfies the hydrogen's duet rule. Then attach the chlorine to the nitrogen, which satisfies the chlorine's octet rule. Since the nitrogen has 3 bonds attached to it, it needs 2 more electrons, so add those electrons at the top, so the nitrogen's octet rule is satisfied. Count the number of electrons in the drawing. There are 8 between chlorine and nitrogen and 4 between the hydrogens and nitrogen, and the lone pair is 2 electrons. 8 plus 2 plus 4 is equal to 14. Since the substance has the number of electrons needed, the drawing is complete.